Welcome. In this video we're going to be talking about how to graph f prime from f, how to graph the derivative of a function based on the graph of the function itself, and also how to graph the function given the graph of the derivative. Don't worry about this stuff here. Worksheet for week 3. I stole this from someone from someplace online. Anyway, we're going to be focusing, like I said, on the graphs of f and f prime, getting information about a derivative from the graph of a function and vice versa. And as it says here, in the end, you're going to be matching graphs of functions to graphs of their derivatives. And that's kind of fun, little kind of like puzzle problems. And let's go ahead and remember that the derivative of a function is this limit here, the limit of the difference quotient as h goes to 0. And so basically, if the slope of the tangent line to the graph of f exists, then this limit exists as well. But we're not really, I don't necessarily think about limits when I'm thinking about derivatives. I'm thinking about the slope of the tangent line. So let's look down here at part 1, part A. Are there any values x for which the derivative does not exist? So you should be able to quickly recognize that we have a sharp point at two different spots, and it looks like the x values of -2 and +2, and so that's exactly what we would put there. So the x value of -2 and also +2, where we can see clearly that the derivative does not exist. Because again, what we're looking at is the graph of f of x, and when f of x has any sharp points, then the derivative doesn't exist. And then the other thing we're going to look at is if there's any values of x for which we have f prime of x equaling 0, meaning that we have a horizontal tangent line. And hopefully you can clearly see that we have a horizontal tangent line. Let me get my line tool here. A horizontal tangent line right there. That's a really thick line. We don't need it that thick. So don't mind me. So then we have a horizontal tangent line right there where x is equal to 0. Okay, so that's the other one, where x is equal to 0 and the x value is 0. Yeah. Okay, and we'll go ahead and turn the page. And for part C, basically we're breaking down this function f and answering questions about the derivative. The function has an open interval, or has an interval, on which the derivative is constant. Okay, so the derivative is constant, and that would be right here. Derivative is constant, meaning the slope of the tangent line remains constant. What is this interval? Well, it looks like the interval would be from -4 all the way to -2. Okay. What does the derivative function look like there? Well, if we count, let me get this back here. Okay. If we count down and count the slope of this line segment, hold on, I got to pause and look back. Okay, I got it. I just wanted to make sure because I can't see both the graph and this page at the same time. So anyway, if we count the change in y, the change in y is down 2 and over 1. So we have a slope of -2, and that's what we were being asked. What does the derivative function look like there? The derivative function would be a constant, because if the slope is a constant, then that would mean the derivative function would be a horizontal line. Estimate the slope of f of x on that interval. As I said, I estimate the slope to be -2. And then part D, on which interval or intervals is f prime positive? Okay, well, there's a key concept here between the graph of f and the graph or the value of f prime. If the graph of, let me write that down, if the graph of f is increasing, or moving up, I should say, the graph is moving up, f is increasing, is moving up, then f prime of x is positive. Okay, and that happens right here and then right here. And when I say right here, first I highlighted the graph right here between -2 and 0, and also on the interval from 2 to 4. And so we see f is increasing the graph of f is moving up, and we're always talking about from left to right. So the y values are getting bigger in between -2 and 0, and in between 2 and 4. Therefore, f prime would be positive on those same intervals, because f prime, remember, represents the slope of the tangent line to the graph of f. Okay, and then part E, on which intervals or intervals is f prime negative, and again we have this interval here between -4 and -2, and so that would be one of the intervals between -4 and -2, and then also from 0 to, between 0 and 2. Okay, so when x is equal to 0 to x is equal to 2, we see that the y values on f are getting smaller, and sketching a graph of the derivative on those intervals, we would see f prime being negative. We'll wait till the very end here to sketch the graph. Okay, so we're using all of our answers to the questions to sketch a graph of the derivative. We take a look at our new set of axes, and just by looking at the f of x, the function itself, and then graphing the derivative, the key concept that I had mentioned before is that the graph of f is moving up. That means f prime is positive. Another key concept is that the slopes of all the graphs, slopes of the curve of f of x is always equal to the value of the derivative. Okay, so let's try to put this together. We have -4. Let's see, 1, 2, 3, 4. From -4 all the way to -2, we knew that the slope of that curve of f of x was equal to -2, and so we see that we have a constant. F prime is constant, and remember we have a sharp point right there, and that, I think it was part B or C asking where, maybe it was part A asking where f prime did not exist. Well, f prime doesn't exist at when x is equal to -2. And then if we look at the graph of f, we remember that, and one of the first things I always draw is when we have a horizontal tangent line then to the graph of f, then that means that we have the derivative equaling 0, meaning that the f prime will have an x-intercept. So that's another key concept, is that a horizontal tangent line to the graph of f is an x-intercept on the graph of f prime. That's one of the most basic but the most important connections between f graph and f prime graph. Okay, so we definitely are going to have an x-intercept here at on the graph of f prime. And then if we look at the graph of f, we can see we have to estimate this part. Okay, we know that f is increasing from -2 to 0. That means that f prime is positive on that interval. And I don't really know what the value would be of the derivative from the right when x is equal to -2. And I know it's a little hard to be talking about the graph of f when I'm not looking at it. But nevertheless, I'm going to just pick some value that it looks like it's about 1, looks like about a 45-degree angle there when x is equal to -2, that the slope of the tangent line from the right at that value looks like about 1. But then as you notice, as the x values get closer and closer to 0, the slope of the tangent line gets closer and closer to 0, then eventually hits 0, and then you could see the slope of the tangent line becomes lower and lower, but also negative, and then again at x equals +2, the derivative doesn't exist. So we get something that looks kind of like that in between -2 and 2. And then from 2 to 4, we notice again that the derivative is getting bigger and bigger. So the function f of x is increasing on the interval from 2 to 4, and that means that f prime is positive on that entire interval. Okay, and it looks like f prime is getting bigger. It looks like the slope of the tangent line is getting higher and higher. So if we just kind of pick a value anywhere positive, somewhere above the x-axis, okay, somewhere above the x-axis, we again know the derivative doesn't exist there, so we have to have an open circle. And then as it kind of looks like an exponential graph there, whereas as the x values get bigger, the slope gets bigger as well, something like along those lines. And there's really no way to know for sure what that is unless we had more information. But nevertheless, that's about it as far as the graph of the derivative goes. Again, this is f prime, okay, and that's my estimate for f prime. And just to review a couple key concepts, when if we do f and f prime, okay, and then the f prime graph, key concepts here, if f is increasing, that means that f prime is positive, and the f prime graph is above the x-axis. Okay, so let's keep that in mind. That's a key concept. Okay, same thing with if f is decreasing, f prime is less than 0, and then f prime graph is below the x-axis. I don't know how many key concepts I've given you, but these are big time. Okay, so if f has a horizontal tangent line, then f prime is equal to 0, and that's an x-intercept on the graph of f prime. So this is a big deal. I'd love for you guys to get this. Okay, once you get it, it's really easy, but you know, just like everything else. Now, if f is has a slope, let's see, slope value, it's increasing. Yeah, I think that if you can get those three concepts down right there, that's pretty cool. There's other things too we'll talk about in class, but based on what I said in the video, I'm going to give you guys some chances to match up the graphs of f and f prime, and then we'll also talk about how you go from f prime to f. I think I'll actually do that in the next video, so we'll see then.